Hi, hello everyone. This is your educator, your tutor, your friend Sanjay Vishwakarma. I welcome you all to yet another session of We Learning. We Learning is a platform which focuses on providing right to quality education for all. Do watch this session. If you like it, do press the like button, share it with your other friends who are preparing for their boards and competition as well. Subscribe to our channel and do not forget to click on the bell icon so that you never miss any update from us. You can also visit our website www.v-learning.in. All right. All these sessions you will be getting there. Along with that, you will be getting lecture notes also for each and every lecture. So do check it out. Okay. We were doing current electricity, and this is lecture number 7. This lecture is combination of resistors part 2, where we'll be seeing complex and symmetric circuits. Very important session. This is going to be very important. I would like to tell you that watch complete session till the end. All kind of complex questions we are going to cover in this. You would have come across a lot of resistors question where you will find very difficult to solve it, right? Because usually we know only series and parallel. Whenever we see a complex circuit, it becomes difficult for us to solve. Here, from the very basics to the very complex, I have taken all kind of questions which can come across you. All right, see this entire session. Now let's start. We'll be seeing a lot of different kind of ways. You will be enjoying this session. It is going to be very interesting. Take out your notebooks and pens and do it simultaneously. Okay. Now first, potential method type questions. Okay. Sometimes when we see a circuit like this, now can you tell whether it is in series or parallel? No, right? By just seeing like this, we cannot tell it. Because if I remove these wires, then they will be in series. But there is some wire like this, it is connected, like this, it is connected. The tail of this is not directly connected to the head of it. The tail of this is not directly connected to the head of it. There is one more wire in the middle, right? Because of which we cannot tell them as series. So now how to solve this? See, potential method type questions, I'll be going a bit fast also because there are so many methods. So, and I don't want this session to be very long. Okay. But you will understand everything for sure. See, now here if I connect a battery across it, find equivalent resistance between A and B. What does this mean? There is a battery across this, right? Now if this is voltage V, that means this is V, this is 0. So from here I can write this at potential V and this at potential 0. Correct? Now forget this. Potential V, potential 0. Even you can also say potential A, potential B also. In this question, I'm just trying to explain you with potential V and potential 0. In the next question onwards, I'll use A, B, C, D points only. Okay. Now, if this is V, that means this point is at V. From here, if I go, there is a resistor. So there will be a potential drop. Correct? Then after potential drop, here there will be some other potential because a drop is happening here. Now, if I see this particular path, there is no resistance in the middle. Potential drop will not happen, right? There is nothing which is actually dropping this potential. So it will be V. Here also it will be V. Correct? Then from here, if I go again, there is a resistor, there will be a potential drop. So here there will be a different potential. It will not be V. So V will be at 2 points here and here. Now from here if I see this is 0, that means this will be 0. If I come here, there is a resistor, right? Potential drop. So that means from here to here there will be a potential difference, right? Now if I see this particular path, there is no resistance in the middle. So that means here also potential will be 0. Right? No potential drop or no potential gain, nothing is happening. Potential 0, here also it is 0. Now see, there are 2 points, right? One is V, one point is at potential V, one point is at potential 0. Can you see any other potential? Only V is there and 0 is there, right? Now if I talk about this resistance is between V and 0. So now if I mark 2 different points, this resistance is between V and 0. So I'll make one resistance between V and 0. R. This resistance is also between V and 0, right? So between V and 0, again I can make one more resistance. Now if I talk about this particular resistance, this point is V, this point is 0. This resistance is also between V and 0. Each resistance here is between V and 0. So now can you see which kind of combination is this? It's a parallel combination. All these three resistances were actually in parallel. But by seeing this particular figure, this particular circuit, it was difficult to tell, right? But once we convert it like this, now it is very easy to understand that it's a parallel circuit. Now can you write the equivalent resistance? Very easy. This will be R by 3, right? R equal resistances. If they are parallel, they will be divided by the number of resistance. If you know like this, see 1 upon R equivalent is equal to 1 upon R plus 1 upon R plus 1 upon R. So this is 3 upon R, correct? So from here R equivalent is equal to R by 3. Got it? Potential method type questions. A lot of questions you can solve from this particular method. All right, this is R. This is also R. Now let's move to the next one. This particular circuit. Try it on your own. See here, this point is at A, so this is also A. From here, this point will also be A. Correct? We just have to mark points across R resistors, right? This point will be A. This is B, so this point will also be at potential B, let's say. This point will be B. There is no other resistance here. Now see, there are total how many points? 2, A and B. So I'll mark A here, I'll mark B here. See, these three resistance are between A and B, and these three are in series. There is no other wire from the middle. The tail of this is connected to the head of this directly. The tail of this is connected to the head of this directly. These three are in series and they are between A and B. So between A and B, can I make these three resistances in series? R, R and R. Then this resistance is also between A and B. Between A and B, the other resistances. Correct? Now can you do it easily? These three are in series. This is in parallel with it. So it will be 3R. Then here it will be R. This is A. This is B. How much this will be? 1 upon R equivalent is equal to 1 by 3R plus 1 by R. To make the denominator same, I can write 3 here, multiplying both numerator and denominator by same. This will be 3 plus 1, 4 by 3 R. R equivalent is equal to 3R by 4. Clear? I hope you got it. Easy it is. Now can you do these kind of questions where some wire will come from the middle and you will be thinking what to do, right? Potential type questions these are. Next, try doing this one. A bit more complex. From easy, we are moving to difficult ones. Okay. Try doing this one. Find the equivalent resistance between A and B. Now this time, again, let us take this point. See, this is A. So this point will be at A. Right? Then from here, there is a resistance. There will be a potential drop. From here to here, if I move, this point will also be at A. Now again, from here, if I move, there will be a potential drop. Any other point at A? No, only these 2 points will be at A, right? From here, if I see, there is a resistor directly. So there will be a potential drop. That means there is only one point B, that is this side. There is no other point B. Now then, this point is also there, this point is also there, this point is also there. What to do? These two are in series. There is no other wire between this. The tail of this is connected to the head of this, right? Now, here, let us take this point at some potential X. Okay, we have just considered it. Because A, there are only 2 points which are at potential A, only 1 point at potential B. Now there are other points also, because we have to see both the ends of the resistor, right? Both the sides of each resistor. Here also both the sides of each resistor. Here we know these two are in series, right? So now this point let us mark as X. So if this point is X, this point will also be X. And if this point is X, this point will also be X. Are yes or no? Now how many total points are there? 3. A, B and X. A, B and X. See here. Let us mark one point A, one point B, and here one point X. Now see this particular resistor, it is between A and X. So if I make one resistance between A and X, it will be like this. Correct? This resistor is also between A and X. Again, one more resistor between A and X. This resistor is also between A and X, right? See the 2 points. So here one more resistor will be between A and X. Now see, these two resistors, they are between X and X. Is it possible? Across the resistor, both the points, the potential is same. That means if the current is going from here to here, there is no potential drop. Is it possible? See, if I make this as an equivalent resistance, it will be 2R because they are R and R in series. Now, if the current is going from here and it is crossing this 2R, there should be a potential drop, right? But these 2 points are at same potential, X and X. There is no potential drop. That means the current is not going there. I can remove this wire. Clear? I can remove this wire. This is basically, see, current chooses the path with least resistance. Here, if the current is going, now from here also it is reaching the same point, from here also it is reaching the same point. So current will choose this point. It is basically short circuited. If you see, these 2 points are same points. If I take a wire and just join this like this, these 2 points are same points. Between X and X, how can some resistance be? There has to be 2 points between which we can put anything, right? Between one point, there is no between one. Between can be only if there are 2 things, correct? So this particular thing is basically a short circuit. These 2 resistance are invalid. It doesn't make sense. It doesn't make sense. Clear? So from now, these 2 points are X and B. This resistance is between X and B. This is R, this is R, this is R, and this is R. Now can you solve it? Easy. This is R by 3. Correct? This is point A. Then from here, no need to mark point X now because it is directly in series now. This is point B. R by 3 plus R. Series, right? So this will be 3R, 4R by 3. R equivalent is equal to 4R by 3. Clear? Just understand the concept. If some calculation mistake happens in the middle, ignore that. The main point is to understand the concept. I hope now all the potential type questions, all these kind of questions you'll do if you see any circuit like this. All right. Let's move to the next type. Star delta method. Again, very important. Many questions will not be possible by the potential method. Then you will be using star delta method. Okay. Suppose if you see any circuit like this, this is connected to some other resistance, this is connected to some other resistance, this is connected to some other resistance. Fine. Now, for now, we are not talking about anything other than this. Fine. We are just talking about this circuit, which is looking like a delta, right? It is looking like a delta only. Now, if there is a circuit which looks like delta, one resistance is here, one resistance is here, one resistance is here. Let's say this is RA, this is RB, and this is RC. We can convert this circuit into star form. Okay, star form means like this. The points are same. A will be here only, B will be there only, C will be there only. Okay, then whatever I told, one resistance, if it is connected, any circuit is connected like this, it will be same. Okay, the points will be same. Only this delta will be converted into star. Now, if this delta is converted to star, these resistance, let's say this is R1, this is R2, this is R3. Fine. Do not remember the formula, understand the concept. From delta, we can convert this circuit to star. Okay. If, see, some questions, we have to convert it in this form, then the question will become easy. In some questions, it will be given like this, but it will be complex. If we convert it into delta, that question will become easy. Okay. So however the question becomes easy, we have to do the conversion that way. So first we are going to learn how to do the conversion. Fine. Then we will be applying in the questions and seeing how actually it makes them easy. Fine. See here. Converting this delta into star, how we'll do it? If I place this particular thing here, let me just show you. I'm just converting it into star. This is R1, this is R2, this is R3. So now the value of this R1 will be, I hope it will come there. Fine. The value of this R1 will be C. What you have to see, this resistance we have to find out. So the product of the neighboring resistances, RA and RB, the product of the neighboring resistances divide by the sum of all the resistances. Clear? This is R1. Product of the neighboring resistance divide by all RA plus RB plus RC. So what will be R2? Okay, let me write from here. This RC I'll write here. From here I am writing so that all the resistances will come. RA RB upon RA plus RB plus RC. Can you tell the formula for R2? Just see. Product of the neighboring resistances divide by the sum of all the three resistances. Clear? So here this will be RA into RC divide by RA plus RB plus RC. All right. Now, R3, this is R3. Product of the neighboring, that is RB into RC divide by RA plus RB plus RC. So if delta is given, then we can convert it into star and these will be the resistances. Fine. Just see. Product of the neighboring resistances divide by the sum of all the three resistances. Note it down. Now let us see if this star is given, how to convert it into delta. Okay. This is star. Let's say again, this is R1, this is R2, this is R3. Okay. I have to convert it into delta. This is RA, this is RB, this is RC. Fine. Now, RA, how we'll write? See here, RA will be the value of RA. Now, this star I have to convert into delta. Let me just make this delta here. I'm converting, okay, let's say. Fine. Now this is RA, this is RB, and this is RC. How to write the formula for this RA? Now if you see, this is like a cap. Like this becomes a triangle, right? This is like the cap of this RA. So what you have to do is, the sum of these two resistances, R1 plus R2 plus, again one more plus. There will be total 3 terms. Okay, remember, sum of these two, then the product of these two, R1, R2, divide by the one which is not in the cap, the third resistance, the opposite one, the resistance which is at the opposite side, which is in the front, you can say. Fine. So this will be R3. Clear? See here, RA was there. First, what we did, the sum of this resistances on the cap of this RA. This is RA. This is like the cap, right? And this is the one which is at the front. So this RA we have to find out. This is R1, this is R2, this is R3. So sum of these two resistances which are at the cap, R1 plus R2 plus the product of R1, R2 divide by the third one, the one which is in the front. Fine. This is the formula. Remember it this way. There will be 3 terms. All right. So now can you tell me the formula for RB? RB. See, these are the two resistances at the cap. The sum of the cap, R1 plus R3 plus third term will be the product of the cap, R1, R3 divided by the one which is in the front, that is R2. Clear? Now RC can you write? I'll write here. RC is equal to sum of the cap, R2 plus R3 plus the product of R2, R3 divided by the one which is at the front, R1. First the sum, then the product divided by the other one, the third one. Okay? Note these formulas. Don't learn the formulas. Why I am telling you to note these formulas? So that you can remember it, how this came, by seeing it, by recalling it. How this RA came, this R1 is this one, R2 is this one. So first we did the sum of this. Then we did the product of these two only, divide by the other one. Okay? Now let us see in what kind of questions we can use it. Now if you see a question like this, is it a Wheatstone bridge? All the resistances are different. See, if I make an equivalent circuit for this, for now, these and these two are in series, these two are in series, correct? See? So at least I can resolve these two. First, the very first step will be resolving these two. This is A. This will be B. Now see, this is 7R. This 2 I have resolved, it will be 3R, right? This is already given as 4R. 5 plus 6, this is 11R. This is 3R. This will be the circuit. Is it a balanced Wheatstone bridge? No. See, 3 by 4, this is 3 by 11. The ratio is not equal. So now how to do this? How to do this? If you put potential method, there will be 4 different points, you will get the same circuit only. If you see this is A, this is B, again there will be a potential drop. This point is at another potential, some different potential, this point is at different potential. Because it's not a Wheatstone, it's not a balanced Wheatstone bridge. So here there will be some point C, here there will be some point D. Again you will mark all 4 points, again you will make the same circuit. Potential method will not work here. What to do? Now the star delta method will work. See, if you see this particular thing, it's a delta, right? Why I have made it in this way? I could have made like a rectangle also. Again, these two I would have resolved and made it here. But to make you visualize, to see that it is like a delta, right? Now see, if this is a delta, can I convert it into star? Definitely. These 3 points are different points. Okay. If I convert it into star, see how it will become. A point is here, A point is here. There will be one resistance like this, one resistance like this, one resistance like this. Or I'll do it in the next page. See here. A is here. One second. Now see, this delta I have converted into star. This is point A. What these resistance will be currently I don't know. Okay. But I know this is one point, this is one point, and after this also there will be one point. See here, A is there, this is this point, right? That point is connected to this resistance, right? Three R. So this will be 3R. This point is connected to 11R. This will be 11R. Then these two are connected to B. This is point B only, right? Now don't tell this point is connected to 7R. This delta only I have converted to star. So now see, this star I have converted, and then these two ends were connected to this 3R and 11R, and this is B. Now can you see it has become easy to solve it. These two are in series, these two are in series. Then this arm and this arm is in parallel. Then at the end we'll get two resistances in series, right? Converting delta into star, this question became very easy. Okay, fine. Now what will be the value of this resistance? Let us write. See here, if I make the star here, something like this I have done, right? This resistance will be, let me make it properly. Okay, this resistance will be product of the neighboring divided by the sum of all, right? Product of the neighboring means 3R into 4R, 12R square, divide by the sum of all, 7 plus 3, 10 plus 4, 14, 14R. R and R will be cancelled, 14, 2 6 are 12, 2 7s are 14, 6R by 7, this will be 6R by 7 or 6 by 7R. Clear? Do you want me to show this calculation? I'll show here. 3R into 4R divided by 3R plus 7R plus 4R. This is what R1 is. Let's say that resistance is R1. Fine. So that is equal to 12R square divided by 14R. R cancelled. This will be 6 by 7R. That's what it is written here. Now this resistance, the product of the neighboring divided by the sum, that is 7 3s are 21. 21 divided by 14 R. 21R square divided by 14R. R will be cancelled. 7 2s are, 7 3s are, 7 2s are. It will be 3 by 2R, correct? Three by 2R. This one, product of the neighboring, that is 7 4s are 28, 28R square divided by 14R. R will be cancelled, 14 2s are, this will be 2R. This will be 2R, right? 6 by 7R, 3 by 2R, 2R. This delta has to be removed and this circuit has to come here. So this is, let me write, 6 by 7R, 3 by 2R and 2R. Now can you solve this? It is easy now. Or do you want me to solve? Let us solve. So this will be 3 plus 3 by 2, 2 3s are 6, 7, 8, 9, 9 by 2R. From here, this will be 1, then this will be 1, then this will be 1, right? This is 9 by 2R. 11 plus 2, 13R. This is 6 by 7R. A point, B point. From here, 9 by 2 and 13, if I take out R equivalent of this, A point, 6 by 7R, this will be, let me do it here, 2 by 9R plus 1 by 13R. 1 upon, let's say R dash something, okay? So this will be 13 to the 26 plus 9 upon 117. 9 to the 27, 7 to carry 117 R square, right? Here there will be R. So this is 35 by 117 R. So R dash is equal to 117 by 35 R. Correct? So here this is 117 by 35 R. Can you see it properly? Okay. Now just add these two. Adding these two, you will get R equivalent. That will be equal to 6 by 7 plus 117 by 35. 6 by 7 plus 117 by 35. This will be, the LCM will be 35. This will be 30 plus 117. 147 by 35. 147 by 35. Correct? Note it down. This is the answer. Just check the calculation also. But I hope you understood the concept. Okay? Shall we move to the next one? Let's see. One more question. This. How much complex it is, right? If you don't know star to delta, you'll see this question and you'll leave it. Correct? There is one more way to solve this question, which is very easy, from which you will get the answer in just 10 seconds. That also I'll tell you. But before that, let me tell you how to solve this by star delta. See, you cannot solve this by potential method. Every point is a different potential, right? 1 point, 2 point, 3 point, 4, 5, 6. You will make 6 points A, B, C, D, E, F, and you will end up making the same circuit again. Fine. So how to do this? See here. First, if you see this inside, there is a delta. Can we convert this delta into star? If I convert this delta into star, what will happen? See, this one resistance will come, here one resistance will come, here one resistance will come. Just imagine these three are not there, right? The triangle part, this is not there. Now it is like this. So these two will join and become one resistance, it's a series. These two will join and become one resistance, it's a series. These two will join and become one resistance because it's a series. So again, finally we will be having a circuit which will be like this. Correct? These are all resistance only. Now this star, I'll convert again into delta. What will happen with this? I'll get a circuit like this. Now you will say, sir, it is the similar circuit which was there before. No, it's not same. Try to understand the difference. Some people would have got the difference, right? There was a resistance here earlier. Right now, there is no resistance. These 2 points are basically same points. These 2 points are same points. These 2 points are same points. So these two are in parallel actually. If I consider this and this point as same, this is one, this is one. These two are in parallel. These two are in parallel. These two are in parallel. Solving these two, I'll get one resistance in this arm. Solving these two, I'll get one resistance in this arm. Solving these two, I'll get one resistance in this arm. Finally, I'll get a triangle where this is point A, this is point B. Across A and B, I have to find it, right? Across A and B. So A and B, here there will be one resistance, here there will be one resistance, here there will be one resistance. Solving these two, I will get one resistance and this one resistance. Finally, the circuit will be like this, right? My drawing is not so good, so ignore that, but understand the concept. So finally, these two, we'll get one because these two are in series. One resistance will be here, one resistance will be here. This is A point, this is B point. Finally, you'll get R equivalent. Got the point? So from here, what we are doing, we are converting this delta into star and then again star into delta. All right, let us solve this. I have told you the concept, try doing it on your own and at the end match the answer. Okay, see here. Let me convert this particular thing into star. So I'll get something like this. Fine. This is given as R. This is given as R. This is given as R. This is given as 6R. This is given as 6R and this is also given as 6. Fine. Now this is 3R. Let me convert here only, then I'll write the values there. Okay. I'll write. What will be the value of this resistance? Product of the neighboring divided by sum of all the three, right? Product of the neighboring means 3R into 3R. This R1, let us write, let's say this is R1. That will be 3R into 3R divided by the sum of all the three, 3R plus 3R plus 3R. That is equal to 9R square by 9R. That is 1R. Or R. All the three resistances are same. So inside also we will get all the three resistances same. Okay, if you have doubt, you can calculate this. Again, product of 2, that is 9R square, divide by sum of all the three, that is 9R. Again R. Here also product of 2, that is 9R square, divide by the sum of all the three, that is 9R. So you will get R only. So this is R, this is R, this is R. See here, this will be R, this will be R, this will be R. Now inside there will be 2R, 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 right? Let us do. I hope you got till here. Okay. Two R, 2R, 2R, and this was already 6R, 6R, 6R. Fine. Now see, this star, I am going to convert it into delta. Okay, 1 second. This is given as 6R, this is given as 6R, this is given as 6R, right? Now we have to find these three resistances because it was star. Now this point is connected, this point will be connected here. All these, this is connected here, this is connected here, this is connected here. These 3 points will be connected to wherever they were connected, right? Let me connect it properly. Now don't forget, we have to find between A and B, this was A, this was B, right? This is A, this is B. This is A, this is B. This is A, this is B. Okay, I have to find these three resistances. See here. I am converting this star into delta. Let me write these resistances. What will be Ra? Here, let us say this is Ra. Fine. What will be Ra? The cap, can you see? Remember the cap? The sum of the cap, that is 2R plus 2R plus, there are three terms. Third term will be the product of the cap divided by the one which is in the front. The third one, the one which is left out, right? Product means 2R into 2R. These two, the sum of these two first, then the product of these two divided by the other one. So 2R into 2R divided by the other one is also 2R. So this is 2R plus 2R and this is 4R square, or let's say 2R will be cancelled. 2R plus 2R, that is 6R. Clear? So Ra will be 6R. This will also be 6R and this will also be 6R. If you have any doubt, just calculate it. Because all the resistances were same, 2R, right? So again we'll get the same only. 6R. So this is 6R, this is 6R, this is 6R. Now see, these two are in parallel, these two are in parallel, these two are in parallel. I hope you can get it, right? See, this point and this point. This is one arm, this is one arm. This point, this point. This is one arm, this is one arm. This point, this point. This is one arm, this is one arm, right? Now, what will be the equivalent of these two? 3R. The resistance will be halved, right? They are in parallel. 1 by 6 plus 1 by 6 is 2 by 6. Reciprocal will be 6 by 2, that is 3R. So here, after this, we'll get a circuit which will be this. This is A, this is B. There will be one resistance here, one resistance here, one resistance here. This will be 3R, correct? These two are in parallel. This will be 3R. These two are in parallel. 6R, 6R. Parallel means half, that is 3R. Now we have to write the equivalent between A and B. From here there is no need to solve. You can solve it on your own. 3R, 3R. So this is 6R. This is 3R. This is A, this is B. Across AB, finally we got the R equivalent, that is equal to 2R. Just check. 1 by 6 plus 1 by 3R. So here, to make the denominator as 6, I can multiply numerator denominator both by 2. 2 plus 1, 3 upon 6R. R equivalent is equal to 2R. Correct? Finally we got. So just see how complex this circuit was initially when you saw. You would have seen circuits like this, right? But if you don't know to convert this, it will be difficult. Now you can do it easily, right? And people who tried it on their own and got the right answer, very good. People who tried on their own and did not get the right answer, still very good. At least you tried, right? Okay, let's go further. Now the same question I will show you by another method where you will get the answer within 10 seconds. Now that is the method of symmetry, okay, where that will be applied only in symmetrical circuits. See here, this, can you find a symmetry here? There is a symmetry. This is 6R, this is 6R. This is 3R, this is 3R, right? This is R, this is R. If I keep a mirror like this, let's say this is one part, half I have made. If I keep a mirror like this, This same part will be reflecting this side, right? There is a symmetry. Same part is reflected this side. So since there is a symmetry, we can solve this question in 10 seconds. I'll tell you the way. But why did I tell this particular way, star to delta and delta to star? Because every time you won't be getting symmetry, right? If suppose all the resistances were different, then you cannot do it by symmetry. That's the reason you should know this particular method also. All right, let's go further. Ladder problem. Again, these are very easy. Find the equivalent resistance in the following circuit. So this is the circuit. Ladder problem means this is an infinite circuit, or somewhere it will be written infinite circuit. It's the same thing. It looks like a ladder. That's why we have written ladder problem. Otherwise, it's an infinite circuit. Now you have to tell the R equivalent of this. Some people will be like, sir, we don't know the number of resistance only. How do we write R equivalent? We can write. Because again, there is a symmetry in this. See? If you see these two resistance, again the same pattern is repeated. Again the same pattern is repeated. Again the same pattern will be repeated. One resistance here, one resistance here, one resistance here, one resistance here. Right? Since there is a symmetry, we can solve these questions. Whenever you will get infinite series, infinite circuit, there will always be a symmetry. Okay? How to do this? You would have done AP, GP in your maths, right? Similar. You just have to find from where the sequence is same. See here. Infinite series you would have done, right? See from here, if I cut and if I make this circuit below, let me see, I am making this circuit here. The circuit which is above and the circuit which is below. Can you see both the circuits are same? Right? Because the same pattern is repeating again and again. If I cut it from here, if I make this circuit here, I have made from here, but still both are same. Both are same. So that means the R equivalent of this circuit and the R equivalent of this circuit will be same because it's an infinite circuit. Right? The R equivalent of this and this will be same. So what I can do is I can remove this entire part and make one resistance as R equivalent. Let's say this, the resistance of this particular circuit is R equivalent, or let's say that is X for now. Small x. Why I am writing as X? Later on, okay, I'll tell. Once you'll see that equation, then you'll understand why I am writing as X. But if you want, you can let it be as R equivalent also. Fine. Now what to do? See here. This is A. There was a resistance. There is a resistance here. This is B. This is R. This is R. There was one entire circuit there. This one, which the resistance of this entire circuit I have assumed as R equivalent or X. Fine. Now can you solve this circuit? Easy. See here. These and these are parallel. So this will be A, B. This is R. This is, how much this will be? Let's see, 1 upon R. Only I'll do. Okay, here only I'll do. 1 upon R plus 1 upon X. This will be 1 upon R dash, let's say. So R dash will be, this will be, see here, from here, X plus R upon Rx. So R dash will be Rx upon X plus R. Correct? I can write it there. Rx upon X plus R. There was no need to do this. Good students will remember that if two resistances are in parallel, the equivalent resistance will be product of the resistance divided by the sum of resistance. That's what it is written. Rx upon x plus R. No need for this. Now see, these two are in series. So finally what we'll get from here, this is A, we'll get one circuit, this will be B. I'm just straightening the wire. R plus this, R plus Rx upon x plus R. What is this? Equivalent? R equivalent, right? R equivalent is equal to R plus Rx upon x plus R. What is R equivalent? This x is R equivalent only. So can I write this R equivalent as x? Now see this equation, x is equal to this. If I solve it, this will be x is equal to xr plus, okay, xr plus r square plus rx. Let me write this also as Rx. Divide by x plus R. See, have I done correct? Now, this x plus R will go here and multiply. This will become x square plus Rx is equal to Rx plus R square plus Rx. Now see, Rx cancelled. Now what we got from here, or let us go to the next page. Forget this for now. I'm continuing this only. So this will be, this Rx will come this side, this R square will come this side, it will be minus x square minus Rx minus R square is equal to 0. Can you see something? It's a quadratic equation, right? That's why I had written x. You could write R equivalent also, but for some students it will be difficult to recognize that it's a quadratic equation, right? It will be R equivalent square minus R into R equivalent minus R square. A lot will recognize though, right? So this will be, we have to solve this quadratic. X is equal to minus b plus minus root of b square minus 4 AC. Minus means this is already minus, minus minus plus, right? 4 AC. A is 1, C is R square, 4R square. Divide by 2. I hope you know this formula, right? So this will be 4 plus 1, 5. R square will come out. R plus minus root 5R by 2. Two answers. But there has to be only one answer. See this. If I make this R common, this will be 1 plus minus root 5 by 2. 1 plus minus root 5 by 2. That means two answers are R is equal to 1 minus root 5 by 2 are equivalent. This is x. X is R equivalent only, right? Or let me write x here now. Later I'll write. Otherwise some people will be confused only. X is equal to 1 plus root 5 by 2 into R is also there, right? Now this is negative. Root 5 is bigger than 1, greater than 1. 1 minus something greater than 1 is negative. This is not possible. Resistance cannot be negative. Resistance cannot be negative, right? So resistance can be positive. So R equivalent will be 1 plus root 5 by 2 into R. Clear? I hope you understood this question. Note it down. So whenever you see infinite circuit, try to see the symmetry, try to find out the pattern, right? Try to find out the pattern and then solve it. Try more. This is one example I have shown you to make your concept clear. Whatever questions I am showing here, just for making your concept clear, try more questions on your own at home. All right, let's go further. I hope everyone understood this. I am going to erase this now. Okay, symmetric circuit. Now, again, very important. A lot of questions comes on symmetric circuit also. Okay, a lot of complex questions can come on symmetric circuit, but there are ways to do it. There are two ways to do symmetric circuit questions. One, mirror symmetry. One, folding symmetry. Folding symmetry. Fine. In some questions, you can apply both. In some questions, only mirror will be applied. In some questions, only folding will be applied. We'll see all kind of questions. Okay. What is mirror symmetry? What is folding symmetry? That also I'll tell. See here. Can you see this question? You cannot again apply potential method. There are so many points. You will end up with the same. Though you can apply star delta method, no doubt. That method is applicable. Okay. But it will take a lot of time to get the answer. You will get, no doubt. Fine. Now, since all the resistances are same, let's try to find the symmetry. See here, if I keep a mirror here, it is symmetrical about this mirror, correct? Whatever is this side, the same is this side. If I keep a mirror here, again it is symmetrical. Whatever is above, the same is below. So now, if we are going to apply mirror symmetry, we will never apply it along the line AB. Always understand. Now, in this following circuit, we have to find equivalent resistance between A and B. It's not written, but between A and B. So, between the points, between the terminals, if I have to, the terminals which are given, I have to find the equivalent resistance. I cannot put a mirror along this line. Fine. For that, I will use folding symmetry. In this particular question, both the symmetries can be used. You will get the same answer. Okay. I'll solve these questions using both. Then we will see questions where in one question only mirror will be applied, in one question only folding will be applied. Here both can be applied. Let's start with mirror symmetry. Mirror symmetry, you will never put a mirror on this line. Other than that, you can put mirror anywhere. Okay, we do not have to disturb the terminals at all. Now see, we can put a mirror here. So if there is a mirror symmetry, method 1, mirror symmetry. If there is a mirror symmetry, what we can do is we can actually remove all the wires which are there along the mirror. If there is any connection along the mirror, we can remove that connection. Whether it's a short circuit, suppose there is a resistance is not there, if it is a direct wire also, I can remove it. Fine. Why? Understand, since there is a symmetry, whatever is this side, the same is this side. What does this mean? These 2 points will be at the same potential. That's what we learnt in the Wheatstone bridge, right? These 2 points will be at the same potential. That means there will be no flow of current from here to here. Current only flows when there is a potential difference. So if I connect a wire also, a resistance also, a capacitor also, whatever I connect here, the current will not flow. These two are at the same potential. So symmetry tells us this. Symmetry tells us, by looking at the figure, you can tell which 2 points will be at the same potential. So since these two will be at the same potential, we can remove this wire. If you want, you can make a note of it. Okay. Mirror symmetry. Mirror symmetry. One second. One diagram will come there. I'll write here somewhere below. Mirror symmetry is along the line CD. So points C and D will be at same potential. Okay. We can remove this particular wire. If we remove this, the circuit will become like this. Now can you solve it? Yes, right? Now it is easy to solve. These two are in series, these two are in series, these two are in series. So the circuit will be two R, two R, two R, A and B. From here, we will get the equivalent resistance. What will be it? 2R, 2R, 2R. By 3 it will be, right? 2R by 3. R equivalent is equal to 2R by 3. If you want, solve it. 1 by 2R, 1 by 2R, 1 by 2R, 3 by 2R. That's 2R by 3. That's the answer. See, initially when we looked at the question, it was complex, right? But if we know this particular thing, it became very easy. These are the short tricks to find the resistance. So in every question, do not go with potential method. It's not possible. You have to look at the questions, analyze it, and get to know immediately which thing we have to use. Okay. Now the same question I am going to do with folding symmetry, method 2. Folding symmetry. Folding symmetry. Folding symmetry will always be applied along this terminal AB. Okay. Mirror symmetry will never be applied along this line AB. Folding symmetry will always be applied along this line AB. Make a note of it. Okay. Make a note of it. From here, if you see, the part which is above this AB and this part, both are symmetrical, both are same. I can actually fold this. From here, what I'll be doing, I'll fold. If I'll fold, okay, what will happen? Understand. These 2 points will join, C and D. C and D will join, right? So now, if C and D will join, this and this will become parallel. This and this will become parallel. This and this will become parallel. See, C and D are joined here. So this was already there, this was already there, this was already there, these three. Now this one which was here, this overlapped this, correct? These two are parallel now. The one which was here, like this will be parallel to this resistance. The one which was here, this will be parallel to this resistance. Now can you solve? See, there are only two terminals, this terminal, this terminal. These two are parallel. This terminal, this terminal. These two are parallel. This terminal, this terminal. These two are parallel. If these two are parallel, this will be R by 2, R by 2, R by 2. They will be halved, right? So now, from here, I'll get this. R by 2, R by 2, R by 2. Now these two resistance, one more thing, will be same, right? Because when I am folding this C is actually connecting to D. Rest entire circuit is same. Nothing is happening to the circuit, right? This is completely same. This is one wire. I am folding just this part and overlapping it here, right? So this will be R and R only. Now can you solve it? Still, these two are connected, right? These two are connected, right? Does it look like a Wheatstone bridge? Balanced Wheatstone bridge? This is R by 2, this is R by 2. The ratio R upon R by 2 and here R upon R by 2, same. Can I remove this also? This point and this point will be equipotential. Or you can look this way also. See, there is a mirror symmetry. This part, if I put a mirror here, this and this, that means these two are At same potential, I can remove this wire also. Now can you solve it? It became easy. R by 2 are in series. These two are in series, so it will be R. This is 2R. 2R. R. R equivalent is equal to 1 upon 2R, 1 upon R. 2R by 3. Just check. You'll get the same answer. In previous also, when we did from mirror symmetry, what was the answer? 2R by 3. When we did by folding symmetry, what is the answer? 2R by 3. Because the resistance will be same, right? However you do, whatever is the method, the answer will be same. Understood where to apply mirror symmetry and where to apply folding symmetry? Okay. Now let's go to the next question. This one. What do you think? Is it symmetrical? Just see. Can we apply any of the symmetry, mirror or folding? If you see AB, it is not symmetrical. We cannot fold this and this. It will not overlap exactly, right? Okay. If I keep a mirror like this, see the part which is this side, the same part is this side. Mirror symmetry. Mirror symmetry. If I keep a mirror here. Now what I told? Any connection along the mirror, I have to remove, right? This point and this point will be at the same potential. I'll remove this wire out. I'll remove it out. If I remove it out, the circuit will be like this. Now can you solve this? These two are in series, 2R, 2R, R. Clear? From here, this will be 2R. This will again be 2R. This will be R. This is A. This is B. From here, I can write R equivalent directly. How much it will be? 1 upon 2R, 1 upon 2R, 1 upon R. I can write this as 2 upon 2R. Two, three, 4. 4 upon 2R. R equivalent will be 2R. R by 2, I think. Clear? See calculation, 1 by 2R, 1 by 2R, 1 by R, 2 by 2R, this will be 2R, this will be 1, 2, 3, 4, 4 by 2R, 2 2s are 4, R by 2. That is what R equivalent is for this particular circuit. Okay, now let's see one more. Find the equivalent resistance in the following circuit. How will we do this? It's not the similar question which we did before. See the resistances. This is 2R, this is 2R, this is 2R. In the last question, everything was R. Right? This time, this half is R, this half is 2R. Can we apply mirror symmetry here? No, right? See, if I keep a mirror, this side it is RR, this side it is 2R. We cannot apply mirror symmetry. But can we apply folding symmetry here? Just tell. Yes, this is 2R, this is 2R. If I just fold it like this, this will completely overlap this will completely overlap this R, 2R, 2R. And no effect happens on this because we are just folding this part. This is one straight wire, correct? So how it will become? Now, if this will become this, we know that this will become parallel to this will be parallel to this will be parallel to this. Now you should know To do directly, whenever we'll be doing folding symmetry, what we have to do is we have to remove this upper part and the resistances which are below, we have to make it half. Correct? That's what we did in the last question. See, I'll show you. Here, we folded it. But at the end, if you see, all the resistances which were below this AB line, they were halved. See here. It was like this. The upper part is removed. This R and R is there. Only the upper part. This line will be there. These three resistances became half. Correct? So now, whenever we are applying folding symmetry, you should know this. What will happen? I have folded this. This will be no doubt parallel. This will be parallel. There will be one more parallel. R, 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 2R, 2R. Correct? Got it? Now, this R by 2, this R by 2, this 2R, 2R, R. So these three resistances will be R by 2, R by 2, and this will be R. Now see here, how to do this? Is it a balanced Wheatstone bridge? This resistance and this resistance, R divided by half of R. Here also, whatever the resistance is, divide by half of that resistance. It is a balanced Wheatstone bridge. If you see, R upon R by 2. Here 2R upon R. This is 2, the ratio. Here also, this 2 will go up, it will be 2. 2 is equal to 2. This and this, both the arms are balanced, right? That means point D and this point will be at same potential. Or again, you can apply mirror symmetry here. Keep a mirror. No, you cannot apply a mirror symmetry here. You cannot apply. You can just see the balancing of the Wheatstone bridge. Fine. I can remove this particular wire. If I remove that, it will become like this. If it becomes like this, now can you solve it? See here. R, 2R. So many R's are there. Do not sing R. Fine. Just focus here. R, 2R. Now this R by 2 and R will be 3R by 2. R by 2, R by 2, 3R by 2. Now solve this. What is there in this? 2 by 3R plus 1 by 2R. So this will be 3 by 6R. This will be 4 by 6R. So from here, 4 plus 3, 7 by 6R. R equivalent is equal to 6 by 7. Correct? 2R, 3 by 2R. Just check the calculation. That's all. 3 2s are 6. 2 2s are 4. 3, 4, 3, 7. 7 by 6. 6 by 7. This is the answer. Fine. Now, let's see the next one. Again, one more complex question. This will be going to be the last question for today. Okay. Find the equivalent resistance between A and B in the following. Try it on your own. Just see whether you can do it or not. Try it on your own. Can you see any kind of symmetry here? All the resistances are R. Fine. Can you find a mirror symmetry? There is a mirror symmetry. See here. If I put a mirror like this, there is a mirror symmetry. If there is a mirror symmetry, what we can do? All the connections along this, if you keep a mirror here, any connection which is along this mirror, I have to remove it. So what I'll do is, this I can separate. This will become like this. This will become like this. I can separate this. Now then these two resistances will become in series. These two resistances will become in series, right? Then this series and this one will be parallel. This series and this one will be parallel. Solve it. You will get 3 in series. Here you will get 3 in series. Here you will get 2 in series. Then again 1, 1, 1, 3 in parallel you will get. You will be solving it. But now you know both the kind of symmetries. In some questions both symmetries will be applied, right? But always remember, most of the times, or just see and understand yourself by the logic, which will take less time. What I have seen generally, folding symmetry takes less time because we have to remove this half circuit. Then we have to work only on the half circuit. In folding symmetry, we remove half circuit and the lower half, all the resistances will become half, right? Since we are working only on the half circuit, the time consumed is less. So here, both the symmetries are applied. You can do with any, but if you want to save your time, use folding symmetry. Use folding symmetry. Fold it like this. This part will overlap this, or you can remove this. This RR will be same. Rest all the resistances will become half. This R, 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 parallel. Right? Now again, if you see, there is a mirror symmetry. First, what we did, folding. If you apply mirror symmetry at first only, again it will be done as I already showed you, right? Now see here, this, if I keep a mirror here, this and this are symmetrical. So can I remove this connection? So here what I am applying is mirror symmetry. Mirror symmetry. So if I apply this, it was like this, it will become like this. Now it is easy. These two are in series, right? So this will become R. This is R by 2. This will be 2R. 2R. This will be R and R by 2. R and R by 2 will be parallel, right? 1 upon R, 2 by R. R by 3. That's what is written. R by 3. Now all these three are in series. This is again in parallel. I hope now you can do it on your own. This will be R by 2, R by 3. R by 2, R by 2 is R. R plus R by 3. 3R plus R, 4R by 3. 4R by 3. So this will be 2R A, B, 4R by 3. Parallel they are. So 1 upon R equivalent is equal to 1 upon 2R plus 3 upon 4R. Again, if I multiply 2 in denominator and numerator both, this will be 2 plus 3, 5 upon 4R, right? 5 upon 4R. So R equivalent will be 4R by 5. R equivalent will be 4R by 5. Clear? Such a complex circuit, see again. But since it was all the resistance were same, you could do it with symmetry. But suppose the resistances were not same, star delta method, that will work. All right. So don't worry. I have told you all the ways, the potential way, the star delta method, right? If you get infinite series, that also. If you get symmetrical circuits, that also, right? Star delta can solve a lot of questions. Clear? All kind of questions now you will be easily able to solve. Just revise this session, this particular session again. Okay? Try doing all these questions on your own. Clear? Got everything or things went bouncer? Practice it. You will get it. There is one more type, that is resistances on a cube. There will be a cube. I will show you here. There will be a cube. Each side of this cube will be having resistance. Every wire will have resistance, or let's say we'll put resistance on each edge. On each edge, how many edges will be there total? 12, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 resistances will be there. Then they will ask you to find the equivalent resistance. Complex, right? But once you know the way, it will be easy. You can do it by symmetrical method also. Fine. This particular thing, why I have not kept here, it will take some 15-20 minutes. The session will become long. That's why. This I'll explain you after Kirchhoff's law. These resistance questions which we discussed today, all the questions can be done using Kirchhoff's law, right? Kirchhoff's law, you can do all these questions. Fine. So now, this particular thing, I'll be explaining you after teaching the Kirchhoff's law so that I can tell you how you can use that particular law to get the resistance. Along with that, I'll be telling other methods also. Okay. Here in this cube, there will be again three things. One, along the body diagonal. One point is this, one point is this. This will be A, this will be B. This will be body diagonal, the diagonal which is passing through the body. In chemistry, you would have seen body diagonal, phase diagonal, right? Phase diagonal means this is one phase, along this only, they will tell you, right? And then along the edge, this is one edge, this is one edge of the same phase. Along this, they will tell you to find, across this, they will tell you to find the equivalent resistance. These three are cases, different cases. Actually, people will learn the formula for them, but we'll discuss how to solve it. All right. For now, just understand these ways, you will be able to solve all the questions. Okay, practice. In the next session, we'll be seeing cells, EMF, internal resistance, and combination of cells. We have seen combination of resistances. Now we'll see combinations of cells also. If you liked today's session, if you understood today's session, do press the like button. Share it with your other friends who are preparing for their boards and competition as well. Alright, subscribe to our channel and do not forget to click on the bell icon so that you never miss any update from us. Okay? You can also visit our website www.v-learning.in. You will be getting all these notes, all these lectures, all these sessions, video sessions there. Along with that, you will be getting lecture notes also. So do check it out. Okay? We'll meet up in the next session. Till then, keep learning from V-Learning. All the best.